In this video, we want to extend our ideas about indices and to one where we're looking at the situation of zero indices and fractional indices. So here we want to start with a little table. We want to have a look at some values that we've got here. So we're looking at 3 to the power of 3. Well, we know that's going to be 27. And then we go down to 3 to the power of 2, which is 9. And then 3 to the power of 1 is 3. So if we have a look at what's happening as we go down each by 1 every time in the index there, if we have a look from going 27 to 9, then 9 to 3 and look for a pattern, we should see that every time we divide by 3, because 27 divided by 3 is 9 and 9 divided by 3 is 3. Now we want to keep going. So if we look at our pattern here, we should see that should be 0, because 3, 2, 1, 0. And we keep dividing by 3. We get 3 divided by 3, which would give us 1. So 3 to the power of 0 is equal to 1. And then if we get 3, then our next one should be negative 1. So we're starting to get what we call a negative indice. But again, what will we do with our pattern? Well, our pattern would keep going down by dividing by 3. And 1 divided by 3 is 1/3. That looks interesting. Keep going with our pattern. Minus 2, divide by 3. 1/3 divided by 3 is 1/9. And 3 power minus 3. Again, we divide by 3. And we get 1/27. So we start to notice that negative indices start to give us fractional values there, because we keep just dividing by 3 to get to the next one. So every time we go down one indice, it's the same as dividing it by 3. Now if we have a look at this one, let's just rearrange this. This is the same as saying 1/3 to the power of 1. It's the same as saying 1/3 squared. And this is the same as saying 1/3 cubed. So what's this demonstrating? Well, it's demonstrating two things for us. The first one is that anything to the power of 0 will give us 1. So this is an example with 3, but you could have done the same with a 4 in there or a 5 and getting those values. And you can throw it into your calculator and put any number and put it to the power of 0. It's going to be 1 because they'll follow those same patterns. And then also the second thing we want to notice is that when we start to get a negative in our indice, it starts to indicate a fraction. So they're the two big takeaways we want from this table, is that 0 indice indicates that our answer is going to be 1, and a negative indice indicates we're going to get a fraction. So there's a little summary. A to the power of 0 is equal to 1. Obviously a can't be equal to 0. A can be any term. It can be a pronumeral as well. So there's an example. And then if you've got a to the power of minus m, that would be the same as 1 on a to the power of m. And a to the power of m is equal to 1 on a to the power of minus m. And remember, looking at these, remember that's a reciprocal. That's a reciprocal there. So if we had 2 on 3 to the power of minus 1, that would be the same as saying 3/2. So putting it to the power of a negative there would be same as taking a reciprocal raised to that power. So a couple more examples. So if we want to simplify this one, so 7 to the power of 0, well, we know anything to the power of 0 is 1, plus 2 to the power of 0, and then the power of 0 is 1, so that would be 1 plus 1, which is 2. 3 times y to the power of 0, so the 3 is not to the power of 0, just the y, so that would be 3 lots of y to the power of 0, which is 1. And that would be equal to 3. This shouldn't be confused with 3y all to the power of 0. Everything's to the power of 0 there because we've got the bracket. So that would just be 1 because the whole bracket is to the power of 0. So just be careful not to confuse those two. They're not the same thing. And this one, if we're putting them in the positive indices, which means we want to get rid of the negative there, well, we know the d to the power of 1 would make it 4/d because the d goes as a fraction. And 3 times x to the power of minus 5, again, x is to the power of minus 5, so it would be 3/x to the power of 5. And again, these ones shouldn't be confused with the idea that 4d all to the power of minus 1 would be 1 over the 4d, because the whole bracket there is to the power of minus 1. Notice the 4 stays on top here because the 4's got no power. It's just 4 to the power of positive 1 there, and d to the power of minus 1. So we've just got to be really careful. We see that a lot, people just confusing the notation, and I see that written as that a lot of times, which it shouldn't be right. So there we go. There's our two rules we want to look at: zero indices and negative indices.